Good morning and good afternoon, everyone. I'm Chris Spinagle from the Warning Decision Training Division. Along with me is Jill Hardy, also from WDTD. I'd like to welcome you to our fifth installment of our Revival of the Storm of the Month series. Today's presentation comes to you from the Storm Prediction Center and the National Weather Service Forecast Office in Norman, Oklahoma. Our presenters are Evan Bentley, Todd Lindley, and Phil Ware, who will be presenting the May 7th, 2020 North Texas Hailstorm, leveraging Warn-On forecast to build forecaster confidence. And with all that being said, Evan, the floor is yours, so go ahead and take it away.
All right, thank you, Chris. So as Chris mentioned, this is a collaboration between myself and then Todd Lindley and Phil Ware at the local forecast office here in Norman. Also want to give a shout out to Randy Bowers. He's kind of our team coach. He brought everyone together for this project, and then he actually even up presenting anything. So I want to give him a shout out before we move forward here. But as an outline, I'm going to go over kind of the event overview in the perspective from the SPC and kind of what we did that day and why. Todd's going to talk about the importance of mesoanalysis in the WFO, and then Phil, as the warning operator that day, is going to jump in kind of a radar overview and talk more about the storm scale analysis of what occurred. Starting out here, here's the 1630Z day one outlook that day. We had a broad slight risk area. This was kind of one of those days where it's a pretty good environment, but storm coverage was expected to be low, and there were some uncertainties we were kind of waiting for further in the day to figure out. Overall, we had a trough digging into the Rockies region there, northwest flow across the Texas Panhandle into southwestern Oklahoma and northern Texas. Zooming in here, and this is at 21Z, here's the 500 flow. We have about 50 knots of flow across most of the region there. For reference, our point of interest is going to be right in here. The storm we're focusing on is going to be here in this region. So looking at 850, your low-level jet axis is actually east of this area. Because of that, and then also, the relative lack of moisture, this really wasn't a big tornado day. We were really looking at more of a hail day with this event. Also, looking at the surface, this is one of those events where the moisture wasn't there initially, and it got there just in time. So you can see 15, 18. By 21Z, you finally got 60-degree dew points up here. So it was kind of a race against time to get the moisture out, to where our initiation zone was expected. So 19Z, Amarillo Rayob shows that you're still a little bit capped, but you're starting to mix out, and you're just about fully mixed. So this is a couple hours before initiation, which was between 21 and 22Z. But also of note here, you can see verification of the 50-knot winds there at 500. You got effective shear of 53 knots, and with the limited storm coverage we're expecting, it was definitely a discrete supercell mode called a day. So looking at our hand analysis here, you can see we had a dry line that extended up into the eastern Texas Panhandle, a warm front that draped here across Oklahoma, and here you can see the thin area of moisture that was streaming northward. There's a little pocket of low 60-degree dew points here near Childress, and that's kind of the area where we did have initiation. And actually, there was a little more of a dry line bulge by 22Z where initiation occurred. So here's about the time of initiation. This is 2145Z. You can see we've got some clustering here and some towers and some lightning starting to show up on GLM. In the 15 minutes prior to this and up to this is kind of what we saw, which helped us have the confidence to amend the day one outlook. So you can ignore this enhanced tier that's in central Oklahoma. That was for storms later in the day coming down with the front. It's this small enhanced tier that we added as an amendment at 2152Z. So why do we wait for the upgrade, and why not just do it earlier? Well, here's what we were looking at that morning. So here's the 12Z href. There's kind of a broad area of UH tracks through here. And looking at each of the individual members, here's the NAM nest and high-res window NMMB. So those, okay, looks like there's pretty good consensus, but then ARW, nothing. And these are at 23Z, by the way. And then the NISL WRF is like, okay, we've got some storms, but they're like farther south is where the stronger ones are. So the bottom line is there's a fair amount of uncertainty here. For what it's worth, you'll see here later, based on what happened, the HER nailed it. This is pretty much exactly what happened. So the HER did a great job here at 12Z, although it's worth noting that by 18Z, the HER had significantly delayed storms to not even forming until 23 to 0Z, and because they were forming so late, they really never got going super strong. And so for as good as the 12Z HER did, through time, it actually gave us less confidence as it trended away. I'm going to talk a little bit about how the Warn-On forecast kind of helped overcome that issue and helped kind of match what our observations were seeing. So Our confidence in the upgrade came from our observation. So we saw the send was nearly eroded. We saw that from the mesoanalysis and also the Amarillo sounding. CI was imminent based on the visible satellite. We saw there was boundary normal flow in a strong cap, so storm mode was expected to be discrete. And really what we were looking at was a day where we had strong to extreme instability and strong shear 50 to 55 knots, indicating that our storm intensity was probably going to be moderate risk caliber, but our storm coverage was expected to be low. So what do we do on a day like that? Well, in this case, once we had confidence that we pretty much know where the corridor is going to be with a strong storm, we were like, okay, a slight risk isn't enough to message this. This is going to be a big, beefy supercell, and we have a pretty good idea where the track is going to be. So at that time, we did upgrade to the enhanced risk, basically where we thought that supercell was going to track. So part of what gave us confidence from the modeling side was the Ware forecast system that was running. You can see through time it actually zeroed in on the area. So 17Z, there's the 18Z run valid at 0Z, the 19Z run, and by 20Z. So you can see really through time it zeroed in on an area there. It's western part of North Texas, just south of the Red River, was really kind of the area that was focusing on, which is where it ended up occurring. Here's a visible loop. You can see initiation here shortly after 21Z. And then the storm just continues to track southeastward, and there was pretty limited storm coverage. Just pretty much just this one. There's one further south that tried for a little while, but wasn't really able to get going. You'll see here in the loop, there's a storm split that occurred right here, and it had a pretty good left mover that was shot off to the northeast. But then you can see here's where the storm tracked here. Looking at the end of the life cycle, it was closing in on Fort Worth. It looked like it could be big problems for them. But, as we'll get to later, Fort Worth was spared, and it's because, by that time, really pretty strong capping inversion across that region. So a quick sidebar here, that storm split we saw there, the WASP did an excellent job actually showing that. Here's this is the 2230Z run. So it was really, we had seen that, and it was really interesting to see that that's actually what occurred in real time. That's something that WASP picked up on well. Just after 1Z, we had to decide what to do downstream as this supercell was moving out of the first watch. So we had to do a small watch of downstream. How far east do we go? So after coordination with the local forecast office, we kept it out of Tarrant County, which is where Fort Worth is, because we knew it was going to be right there in that vicinity where it's going to be ending. And that's because, look at this 0Z ray out from Fort Worth. There was a really strong capping inversion. So we knew it was going to die somewhere in that region. But as we know, when you got these strong supercells and the pressure perturbations going on within the updraft, they can extend well beyond where you expect them to. Before I move on, another quick little sidebar that's neat is if you look, actually, that inversion actually lifts as you go north to Norman and then Lamont. So it's actually a textbook case to kind of show how ascent can act on a capping inversion there. But anyway, moving on, so the WASP really helped with that western extent, where it, kind of the storm died on the western edge of Fort Worth. It showed that for several runs. This is just one here, but it did a really good job showing that that was kind of the area where it was going to die. So it really helped us have a good conversation about, okay, do we want to put Tarrant County in or not? And since it was going to be right on the edge, left it out initially, added it in later, but it ended just about in that area, which was really nice to see that confidence build as well. So finally, before we move on to Todd's section here, I just want to briefly touch on our Mesoscale discussions for the event. Because it was so focused, we were able to really focus in on an area. So this is just before the watch. We're talking about the probable initiation area. But you can even see here, we were talking about probable initiation area. We weren't fully confident that we were going to get storms yet. That was part of the question. And so the previous outlook had gone out 20Z. So really it's between this time and the time we did the amended outlook that we had the confidence from the WASP and from the observations to, okay, we're going to get the storm, time to upgrade. And then we followed the storm throughout, kind of talking about these brief areas and giving our scientific analysis of it. And then we'll touch on it here in a second, but every MD from 2157 and on mentioned the WASP and how great it did and how helpful it really was to kind of our analysis of the environment there. So with that, I'll move on to Todd to talk about kind of the WFO side of the mesoanalysis.
Hi, thanks, Evan. And yeah, so before we talk about the details of this particular case, I want to just stress the importance of mesoanalysis in the WFO. And as forecasters in the operational setting, we're increasingly demanded from our partners to provide some precise convective forecasts, how storms are going to impact particular venues, schools, hospitals over the next 1 to 3 hours. And course, mesoanalysis really provides the foundation for better action-focused messaging, and that's something we have focused on here in Norman with filling the watch to warning messaging gap with actual public actions that our customers can take and be more prepared on the warning scale when storms actually impact their location. And of course, mesoanalysis can improve forecasters' anticipation of storm mode, evolution, trends, and specific hazards and threats, and really through that watch to warning process, increase the effective lead time and support actual warning scale forecast decisions that need to be made. And of course, improve collaboration with our partners at SPC. You can see this unique photo here where even though we have a unique opportunity here in Norman to collaborate with them at times face-to-face, that's an example of that occurring. But these concepts not only apply to severe convection, but also with mesoscale heavy snow bands, fire weather, and flash flooding. And that's been a focus here in Norman with the mesoscale application series of webinars that Randy Bowers has led, where that gives us a venue to look at events after they occur and really develop skills in mesoanalysis and how to apply that to the next 1 to 3 hours and, like I said, improving that effective lead time. So in reference to the Warn on Forecast system and how we applied it on May the 7th, the Warn on Forecast system is a very effective way to enhance your effective mesoanalysis on the storm scale with modeling, and it is an improvement over the CAMs because it so frequently assimilates radar objects every 15 minutes. So it uses the background of the HER-E, if you're not familiar with it, and assimilates 15-minute radar data so that it sees where the storms are actually occurring, where CI occurred, and it can better model the environment in which they're moving into and thus their evolution. So it really reaffirmed and helps to quantify. Your mesoanalyst can know from a strong meteorological background that a storm is moving into a favored environment that may support tornadoes or particularly large hail, damaging winds, whatever your hazard. However, what the Warn on Forecast system really adds is some quantification to those probabilities. What are the probabilities of 2-inch or larger hail? What are the probabilities of particularly strong updraft helicities? And that's what the Warn on Forecast system really provides. It helps quantify and reaffirms a forecaster's analysis. And it gives the mesoanalyst and the warning forecaster much greater confidence on how to message that. So you can see in this example from May the 7th with the storm initiating near Childress, Texas, initially moving towards the east into southwest Oklahoma. And I remember in initial collaboration with our forecaster, the question was, is it going to persist as far east as Altus? But the Warn on Forecast system was showing a very strong deviant right turn to that storm that brought it well into western North Texas and more of a threat towards Wichita Falls. So one way we're trying to effectively translate that message from the mesoanalysis and that watch to warning gap are with action-based graphics that we can disseminate via social messaging. You can see this example when CI was just beginning in the southeast Texas panhandle, and then followed with a subsequent graphic that shows the very strong deviant right motion or turn of the convection that was moving into southwest Oklahoma and actually keeping it to the southwest of Wichita Falls. And you can see at the bottom right, NWS chat message where we stated that the Warn on Forecast system was deviating the storm much further to the right and keeping it to the south of Wichita Falls, and that our best guess was that the largest hail threat would miss Wichita Falls. So this was providing an early, almost all clear message for our partners in Wichita Falls based on the Warn on Forecast data. An additional benefit of Warn on Forecast that we didn't really anticipate during this event, but we did see, was its ability to help with a mesoscale high wind event as a meso-low, meso-high situation formed with decaying convection along the Red River Valley late in the evening, and the Warn on Forecast system did a good job picking that up. So we'll hand it over to Phil.
All right, thanks, Todd. As Evan mentioned, I believe earlier, I was the warning forecaster this day, so I'm going to kind of just go through the what actually happened section and show some of the radar analysis and what I was looking at, some interesting features. So Start off with, this is a map of the storm reports we received. We had a nearly continuous swath of significant hail, greater than 2 inches, all the way from the eastern Texas Panhandle, basically all the way across all of our western North Texas counties as it tracks southeastward. The largest hail report for the storm was actually just to the west of RCWA, right as it formed near Childress, Texas, 3.25 inches. This was not the storm. I don't know, some people might have heard of the 5-inch or greater than 5-inch hailstone we had just a week or two after this with a separate storm that tracked in a similar area. But still, this is a pretty large hail event. We had 5 reports of 3-inch or greater hail and 16 total reports of 2 inches or greater hail. These are some pictures that we received on social media. You can see the baseball there in the top left image, some damage to the siding of that house, and as well as some window damage. And then on the bottom right, we had a really interesting thing that we observed with the storm was we were seeing cloud-to-ground lightning strikes that were 40 to 60 miles out ahead of the core of the supercell in the Wichita Falls area. And we were getting reports of grass fires and whatnot being started by this lightning activity that was just very unusual to see that far ahead of the storm. Looking at some radar images here, this is the 0.9 tilt from the Frederick radar, so we're about 3,000 feet up in the air. This really is a classic significant hail dual-pol image. So what do I mean by that? So starting down on the bottom right with the differential reflectivity, I outlined the area there that it's a very large area of depressed ZDR values less than or around 0. And just kind of overlaying that same area and the other 3 panels, you can see how that kind of traces out. For example, in the reflectivity in the top left, you have this strong reflectivity gradient along the forward flank there, which has been shown to indicate some locally enhanced storm relative helicity size sorting along your forward flank, which is just another sign that there's really strong shear in the environment, and therefore your large hail potential is going to be enhanced. Moving down to the correlation coefficient in the bottom left, we had in that same area with the depressed ZDR, we had reduced CC values less than or around 0.9, which again is another indicator. Usually when you see reduced CC in conjunction with the low ZDR and high reflectivity, that's a pretty classic signature for significant hail. Finally, looking at the KDP, we see a large area of KDP that's not being displayed, and that is due to the CC being low enough that it doesn't display. But you also kind of notice some interesting things with the KDP along the eastern edge of that outlined area. You also see some KDP that's very high, and in combination with these other dual-pol signatures and the reflectivity in that area, that's usually indicative of either a lot of small melting, accumulating hail, or severe hail mixed in with rain, basically just a lot of water-coated hail in that area. So you can see there's a lot of different things that you could pick out from just this one scan. Looking aloft, another classic feature that you'd expect with a strong supercell is going to be a strong mesocyclone that's going to allow for your hail to continually be recycled through the updraft and continue to grow. This one definitely had no shortage of strong velocity values in the mid-levels. This was a 20-minute or so loop here that shows VROT values greater than 70 or 80 knots over that whole time period. And that kind of continued on at different times as well. So another very classic signature there. So this is going to be looping vertically. So as we go up, you see this very large 3-body scatter spike that's not only long in horizontal length, but it's also deep. It shows up very high up in the storm, which is somewhat unusual to see such a deep 3-body scatter spike. But that's just showing you the depth of the hail core is very tall there. And then We also had, as we move up again, as this plays one more time, you can just also see this low CC ring associated with the bounded weak echo region, which shows up pretty well in the reflectivity. So, all of these things in the dual pole, reflectivity, velocity, all of this was really just checking all the boxes as far as large hail. So this storm was really pretty much a slam dunk from the warning perspective. I had no problem keeping at least baseball-sized hail pretty much all the way across our CWA for, the couple-hour period that the storm tracked across. And then finally, we kind of get to a not-so-classic signature. This is a mid-level scan here, so we're about 20,000 feet up, and you'll very clearly, what stands out is these areas of strong rotation in the mid-levels, and they're actually on the periphery of the broader updraft of the storm. And at first glance, you might think, well, you've got a left mover splitting off on the north side, and then you've got some stronger rotation cyclonic on the south side, but it's actually in reverse. So the cyclonic rotation is actually on the north side of the storm, and the anticyclonic rotation was actually basically placed right atop the downdraft, updraft interface along the rear flank downdraft. And you'll see the reflectivity kind of traces that out as well, this arcing reflectivity signature that kind of connects the two counter-rotating pairs. So it's just kind of this really odd, interesting feature, almost like you would see with bookend vortices on a bow echo, but it was basically embedded within a intense supercell. And this feature was kind of noticeable off and on. This is an hour-long loop. You can see it show up now and again throughout this time period, and especially the anticyclonic rotation is very evident through the whole time period, right along, again, kind of the updraft, downdraft interface along the rear flank. We had some discussions in the office kind of after the event. It was like, what is this? And no one was really able to pick up exactly what it was. So maybe some of y'all have an idea of what it might be, but just something interesting I thought I would bring to everyone's attention. But with that, I'll kind of summarize everything, and we can end it and take some questions. But, some best practices that we kind of took out of this is we really want to embrace some of the new products and innovations that are coming out. There's a lot of different things that are being worked upon in kind of the research to operations realm. And one of those is the Warn-On forecast system. I hope that we showed here the kind of utility of that, and we hope that that can kind of continue to grow as we move in the future. But also at the same time, you want to keep in mind your kind of more classic, basic, traditional mesoanalysis skills, analyzing base data, conceptual models, to kind of put a lot of this new innovative stuff in context. And of course, dealing with the telework situation that we're all in right now, leveraging your teleworkers to support operations when you can. We've really found that throughout the season that there's a lot of things you can do from home, and we tried to leverage teleworkers whenever possible. Some lessons learned kind of related to that is, perfect communication in an event is going to be difficult to achieve, and establishing a dedicated coordinator was really helpful in a lot of our severe events this season to kind of coordinate between the people in the office and the teleworkers along with the warning forecaster to make sure that no information didn't get passed along or anything was missed. So with that, I'll kind of open it up to if anyone has any questions, and thank you for listening to our talk.
All right. Well, thank you very much, everybody. I appreciate the variety of questions and topic areas by our presenters. So I want to thank again Todd and Phil and Evan for this nice collaboration presentation. I think it had a lot of good information. Once again, thank you to our speakers, and we look forward to seeing you all in a couple weeks. Have a good one.